Okay, so very funny story. Yeah, I guess someone forgot to press go to live. You know, that happens sometimes. So welcome to the official start of the live stream. How's everyone doing? While this is doing its thing, let me play the intro. Basically, we had connection issues, and for some reason, here we are now. All right, we're almost done with this now. So, anyways, let me do a quick. Let me show you guys what we're working on. While I was doing it, very nice adaptive. We are. That is loud. We are working on this right here. This piece is to demonstrate adaptives, contours, finishing passes, and things like that. Also has a drilling operation, which I've already done because I thought we were live this whole time. Anyway, so we're just doing the roughing right now. So the 2D adaptives. And let me show you guys the feeds and speeds because that's the thing that people care about. We're doing 1/4 inch depth of cut, 0.05 width of cut at 48 inches per minute, which gives us a material removal rate of 0.6 cubic inches per minute, and at 24,000 RPM with a 1.36 chip load. So pretty good so far, and the cam is running pretty good so far actually. So. Unfortunately, we didn't go through much, but oh my god, I was talking this whole time. I actually thought we were live. Wow. So you guys won't get to see the drilling operation, and we're almost done with this too. All right, but I'll go through a little bit more of everything. So yeah, clearly. I should hire someone to monitor the live streams. Or maybe I should just have my phone notifications on so I actually check. So we're almost, I think this is our last adaptive, so we're very close to finishing. Well, I guess we started, just pretend we started late. Good start. Maybe I should just restart this. I don't know though. We can make another part. We'll make it work. Anyways, let me show you guys this part though. That just finished. Wow, look at how quiet it is. Holy shit, that is. Oh, I'm not supposed to say that. That is a lot of chips. Let's turn off the compressor here. Wow. gosh, this is a mess. This is a lot more than I was expecting. So I did a lot more last time. So it's actually not a bad finish, really not. Quite impressive actually. So again, this was very aggressive cut, and you can see that it's really not that bad. And I haven't done the finishing pass yet, and just wow, this is stuck in here. So these pocketing adapters are challenging because they're inside, and chip curing becomes a huge pain in the ass. So that's why we use single flue end mill. So yeah, there's that. Okay, we will make another part then. Let's move all this out of the way. Wow, this is hilarious. Oh, this is a good amount of chips. We do have a bag where we store this. That was all dry too, so very easy to recycle. Let me think what we could do instead. We're so close to finishing this too. Let's see here. Well, I guess we'll do the same thing, but we'll do it slightly higher. You know, that makes sense, I think. So let's go into Fusion and have some fun. So let's take a look here on what we could do. So I was thinking maybe we could just move the part a little bit to the top. Oh, you know what I could do? I could just move the stock around, and I don't even have to redo anything. Okay, let's just move the stock around. All right, problem solved. You see? When you forget to press live, just move the stock around and do it again. All right, well, that was a very good demo. This was a new end mill, and there's barely any screens on it. We're gonna start off by vacuuming this. Oh, we can't really vacuum it now. I have to recycle this. Where's my brush? Damn it. Oh, this is such a fail, dude. Out of all the things that could have failed, this is the thing that prevented us from having a great stream. For those who just joined, basically, I forgot to press go live, and I mean I did press go live, but the Wi-Fi was kind of iffy, and then yeah, the rest is history. So we'll do it over here instead. Do the same exact tool path. And yeah, so securing stock, very important to do. Clearly this was very secure. So there are several things that will happen if you don't secure your stock. Well, I mean, first of all, it's probably gonna go flying outwards, and you're probably gonna damage something. But also, you're gonna have a lot more chattering, which is not very ideal at all. So that can be kind of annoying. So yeah, we're just gonna do the same part. I'm gonna take this off though, and you'll see why in a bit. Well, at least I know these speeds and feeds work, I guess. Oh shoot! Why is someone calling me? Is it dying? Okay, are you testing the latency? What the what? Oh, well, okay, I'll talk to you in the live stream. All right, bye. Yeah, good. Getting a phone call in the stream, perfect. All right, so let's do that again. What's up, guys? Welcome to this machining tutorial. Today I'm going to be machining on a CNC router, showing you speeds and feeds that work very well on a router. This is not going to be the same speeds and feeds you use on a mill, because a router will not give you as much torque and it will not have as much rigidity. So we have to be a little bit more conservative with our speeds and feeds. But I managed to get some really good speeds and feeds on this, so I want to really show you guys. Anyways, so let's get started. Let's pretend nothing happened, you know. I cleaned this table very nicely too before the stream, and clearly now it's not. All right, so we're going to be using machining blocks to be placing the stock so that it's nice and parallel. It doesn't really matter because we're going to be doing a what is that thing called? We're going to be doing a contour around it, but I still like it nice and square, especially with the actual router. This is a 1/2 inch aluminum stock, and we're using actually standoffs on the actual plate. I believe these are M6 screws. I'll have to check that. Yeah, so I'll answer questions in a bit after we start doing this. There are chips in here, so it's going to be a bit challenging for me to put on. We just do a quick vacuum. Well, that's not plugged in. So where was I? Oh yeah, this is a 1/2 inch aluminum stock. We're using 6061, the one for machining. I don't know which one. I don't remember them. And its mounting position is a bit interesting because since we are drilling and we're also doing contours and stuff, I don't want to ruin this beautiful bed. So what I'm doing is I'm stacking 2 pieces of aluminum together. And for the contours to look the best, I've used the double-sided tape method. Well, not double-sided tape, the masking tape method, which is masking tape on the bottom side of aluminum stock, on the other aluminum stock, and use super glue in between. That will ensure that when you finish your contour, the stock, the material, whatever you're cutting really, will stay in place so you can do a nice finishing pass, and it'll also help with surface finish. Because, you know, you're not going to have that part flying around. And most importantly, it's so we protect this beautiful bed. And also, you know, this is very heavy, so it helps with rigidity too. All right, so again, let's just pretend that we're just going off our, well, at least I know these speeds and feeds are good. That's very important. I don't want an end mill break or chattering in the video. So make sure this is nice and tight. I'm just gonna over tight. Oh, look, see, that one is loose. Just make sure these are good to go. I think that's probably the most common mistake to make. Move it back. Is if you don't tighten it enough, and your stock. Actually, the most common mistake is probably not zeroing your Z-axis correctly. So this is on a 2.2 kilowatt spindle. It is using a ER20 collet, which is a very good collet system. Really, really like it. And right now what we're going to be doing is zeroing the X and Y. So the way we do that, at least on this router, is we use a dowel pin, which is basically a 1/4 rod. You can think of it as an end mill without the teeth. Put this on, make sure it's nice and tight. And you want to make sure it's tight, even though we're not cutting anything with this. It's important to be nice and tight so that you don't have run out issues. So we're going to go ahead and go to the current X and Y, which is probably incorrect. Yeah, it probably is. We are going to move the Z-axis down by 6 millimeter. 6 millimeter? That's not 6 millimeter. I don't know why it says that. And then we're going to be using this. This is a device that detects when there's grounding. This whole spindle is grounded because I wired it up correctly. Which turns red when it touches this. So since we're machining aluminum, very, very good. All right, that's fine. I think Alex could join later, so whatever. We'll just pretend we delay this whole thing just for Alex. Anyway, so let's start with the X. Well, I guess that doesn't want to do its thing. what is happening actually. Alright, we'll rehome the machine. Something with its grounding. Yes, exactly. Let's just pretend the stream is happening. Alright, so I can't view comments, that's stupid. Alright, anyways. That makes sense, you know. There's a live button. You need to press live. You can start streaming, but at least I'll know next time because we're doing this again sometime. Very exciting. This is the most exciting live stream, dude. Alright, so we're going to be setting 0. X, here we go. I don't know what is happening to this right now. What? Is it touching anything? Technical difficulties. I wonder if it's something to do with the... Well, this is gonna be kind of bad if I can't do the 0. So maybe this isn't that reliable. Oh, interesting. I've never had this issue before. Anyways, we'll see how it goes. I wonder what is happening that makes it grounded now. Alright, so I'm going to probe the X. Wow. And then probe the Y. Okay. The X is being kind of dumb, but I'll do it again just to be safe. Alright, there you go. So, we have now probed the X and Y. We're not going to do the Z yet because we are going to be doing a drilling operation. So, drilling operations, typically you're not really able to do drilling. I'm just gonna make sure these are tight, but you typically don't do drilling on a router, but I have trust faith in this. So we're gonna be doing a 4mm hole, if I could find a bit, on these two parts. So very simple drilling just to demonstrate what that's like on this machine. We're going to be doing around 6,000 RPM, so not very high, but not very low either. You could do drilling on this for sure. You just have to be a little bit more conservative, again, with how deep you're going. And you typically need to use a smaller drill bit so you can go at higher RPM. So let me show you the ER20 collet system. Very nice system. You want to make sure, very important, that this clicks in like that. You have a nice little click, and that way your tool isn't shaking around when you tighten the actual collet. Now we're going to put the drill bit in, and you don't want to bite on the teeth, but you also don't want to stick out your tool too much because then it's going to have deflection. The thing I love about ER20 is it's very easy to tighten. You really don't need to make it that tight. Like that, simple as that. I use ER11 and it's not as good as ER20 really. Alright, now we are going to be zeroing the Z. So we do do that by putting this on the block. Again, everything is conductive, so I just have to place this under. All right, we are ready to go. Pretend nothing happened, so see, everything is back to normal. So let me start the drilling operation. Make sure you have the right file loaded, or you're gonna run into problems. So let's go ahead and change the camera view. Make sure your air blast system is good. Compressor on. Obviously, port air, of course, that always happens. All right, well, while I was doing this thing, it's not starting yet. How's everyone doing on their chat? Okay, clearly I need, all right, there you go. So we'll do the 4mm drilling operation now. See, straightforward. So that was, like I said, 8,000 RPM. Oh gosh, that's not good. Now we're gonna jog the machine to the center so we can take off the drill bit. All right, so we are ready for the exciting stuff, which is, of course, the actual adaptives. So there's that. We are using a single flute end mill coated, and we go with single flute because on a router we do what's called high-speed machining techniques. So we machine at a very high speed because of its lower torque. So we're machining at 24,000 RPM. Typically, you probably would do like 10,000, but this is on the router. So to take advantage of its maximum power, we would have to do a little bit faster. And a single flute gives us that advantage because it's better with chip clearing and welding, and we basically never have chip welding issues. So those are very important things. Now, important reminder, gonna have to zero the Z. And we want to put that at the back because we had it on the table before, and especially when we're doing adaptives, very aggressive cuts, and it starts to shake and makes horrible sounds. Make sure air blaster system is good to go. We are going to be running this dry, so we could do coolant, but there's no really reason to do it. Adaptives are meant to be very smart with their tool paths, so it considers chip clearing and stuff like that. Okay, so well, I was supposed to have that. Let's get this started. Very, very exciting. This whole stream is just a fail, dude. Okay. Turn on the air blaster, start the job. This whole part will take around 16 minutes. So once it starts doing its plunge, we're doing a helical in for obvious reasons. Once it starts doing its plunge, then we should be good to go. Once it starts doing its actual adaptive and everything sounds good, we are good to go. All right, sounds good so far, so I think we're good to go. What that means is we don't have to worry too much, at least for the most part. Anyways, so this is, we are using, let me rotate this mic. So adaptives also tend to be loudest, so it's definitely a bit loud for sure. But it's not that bad. It's not chattering too, which is very important. And yeah, just doing this dry. What mic am I using? Wow, it doesn't even show me the comments, dude. This is just, this is a joke, dude. Alright, so time to answer some questions. So what mic am I using? I wonder what mic I'm using. It's a little too quiet, huh? Let me wear these headphones so I get to hear myself. So again, this is 0.25 depth of cut and 0.25 depth of cut with a width of cut of 0.05 at 50 IPM, so 50 inches per minute. We're doing a deeper depth of cut because it helps with the cutter tool. It helps with the cutter life, really, because all the flutes, well, not all the flute, but the whole end mill is engaged, so everything is wired the same, so it'll give you a better surface finish. If that made any sense. So we are using the Shapeoko CN router. Of course, this has been modded a lot. So the biggest mod was adding the water-cooled spindle, which allows us to do these aggressive cuts. And it also makes it a lot quieter to deal with and also less maintenance. So the compressor is not the most effective. I'm going to be just blowing the chips away just real quick. So the whole part is 0.375 thickness that we're machining. So we're doing 1/4 inch depth of cut. So it'll take it'll do 2 times to go to its actual depth. What was the speeds for drilling? That is a good question. Let's go to Fusion real quick because this video quality isn't the best anyways. Not very fast. We are doing 300 feet per minute. I don't know. With 10 inches per minute, so very slow, but it does it well if you go slow. And right now with the adaptives, we are doing 50 inches per minute, 24,000 RPM. At, let's see here, 0.25 depth of cut with 0.05 width of cut. So good stuff, good stuff. We'll see how this goes. We have a good amount of stuff that we're going to be roughing out. And then after that, we'll do a facing operation, a finishing. These are adaptives, but they're a lot less aggressive. So we have stock to leave right now, and we're going to be doing another adaptive, which is going to finish it up, make it look very nice and shiny. And then we'll do the contours on the walls. And that's something that's very important to know. On a router, you have deflection. So to get the best surface finish, you want to make sure that the finishing adapters that you're doing also have stock to leave for the radio stock to leave, so that the contours are only hitting the sides of the walls. So you want to make sure you keep that radio stock to leave even for your floor finish, and that way on your wall finish, when it does adaptive, it'll be very nice. So the goal is to put as less stress on the spindle as possible, and that will give you a very good surface finish. And then after all the cleanup part, we will do a contour around, and that's when we're going to use the coolant, so that'll be pretty exciting. And then after that, hopefully it stays in place. We'll see. If it doesn't stay in place, whatever. But if it stays in place, we'll do a nice finishing pass around the whole part. So pretty straightforward. Let's see how we're doing here. Still doing this adaptive. It's almost done. So you can hear that it's a lot quieter when it's doing its second step down. And you know, that's just because it's a lot less material engaged. It's no longer at 0.25 depth of cut. So it's no longer doing its full depth of cut. All right, now for the plunge, or not really plunging, helical in. Let's see how it does. So that little bottle that you see on top, yeah, the circular ones are always the loudest because it's engaging the cutter 100% of the time, basically. That little bottle that you see on the top, I don't know if you guys see it on the stream. That is the coolant. So that is we're using mist coolant, and that's 95% distilled water and 5% of the actual coolant. Damn, we lost views. How sad is this? Anyways, so yeah, very exciting, you know. Pretend nothing happened at all. Yeah, so yeah, use the use the fact that the end mill or anything is conductive to help. Wow, that is a pretty aggressive cut. So yeah, so we have it's a pretty good mixture, I would say. It smells quite nice. I prefer the smell of coolant compared to tapping fluid, so I prefer to use coolant a lot. Obviously, right now we're cutting dry, so. All right, so I'm gonna just check in on chip clearing. Probably help it out a little bit. So the important things that you can actually know, you know a lot about how your feeds and speeds based on the sound that you hear, like if your toolpath are good. Like you want to make sure it's a good consistent sound. Obviously it's not chattering, and chattering just means that, you know, there's a lot of vibration buildup. You really want to hear, so hear how that sound is relatively consistent throughout, and that's how you know that you're doing a pretty good cut. You can see the chips that are coming out. Pretty decent chip evacuation overall. I would get a more powerful compressor. These kind of adapters are the most challenging because it's enclosed in a circle, so the chips have, you know, they don't really have a place to fly out, so they do tend to, you know, it's not that bad right now, really. But they do have a challenge of coming out, so. It does seem to go a little bit aggressive on the final end right there. Oh yeah, and I'm assuming the coolant is hidden because it's a huge bottle. This is a very we're doing mist, so. Well, we will be doing mist. So we're small. 4 minutes left. So this is, again, this whole adaptives take around 15 minutes, which is very, very good for considering how much we're mailing out. So yes, we do have, like I said, radio and axle stock leaf, so it'll help with cleaning it up. Alright, here we go. So this is the circular part. This is when the cutter will engage 100% all the time when it's doing its adaptive. So it's going to be quite loud. We'll hear how it sounds. We'll see how it does. And yeah, again, 50 inches per minute, which is not very fast, but there it goes. You can hear relatively consistent sound. This is very good. No chattering or anything. So very good start, and that just means that your stock is very well in place. Your machine is able to do it. You know, remain rigid. It's actually not doing too bad on chip clearing. It's not going back into the end mill, which is nice. Alright, now it's going to do its second helical in. Who's watching? I don't know. 5 people watching, that's not bad. And you can hear again much quieter because not that deep. Okay, 2 minutes left, almost done here. Very excited to see how this turns out. Obviously, I already know because we just, this is the second time. So this is where water-cooled spindle really comes as an advantage, because hold on. Okay, yes. This is where water-cooled spindle is. Let me see here. Is a real advantage because there is a lot of chips flying, and if you use air-cooled, then it'll go back into the spindle. So water-cooled spindle is completely sealed up, so it helps a lot with longevity and maintenance. You can see how it's just plowing through the aluminum. Very, 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 very clean. And I think there's one more. Yeah, very short amount of cut, so we can look at its tolerances. There you go. Yay. That is probably that is definitely probably the most wow, there's a lot of chips, dude. That is probably the most aggressive cuts, and that really, you know, pushes the machine rigidity. Everything is very room temperature. Nothing is heating up. The end mill looks brand new. It has very little scuffing on its coating. I'm sure that can be washed out too. Very, yeah, cool to the touch. And chip evacuation helps a lot with getting the heat away from the end mill. So, wow, I don't know how I'm gonna clean this up. Let's switch the camera view here. So now we're going to be doing the finishing, which is actually going to take a while because the step over is not that high, but it's a lot less aggressive. It goes around 12,000 RPM, so much lower RPM as well. So it's just overall more chill. Let me try to move the camera here. I don't know how much you guys can see, but this is actually not a bad surface finish considering that it was a roughing recipe. You get this nice rainbow. It feels very smooth too. So very good start. That might be because I'm using the new cutter too. Alright, so yeah, that's the shape we want. It's always a good start. And we still have our two very nice holes that we drilled in the beginning. I'll just move these chips near the edges so they don't get in the way. Again, I will be recycling this, so. I saw some CNC videos when people got really upset that someone wasn't recycling the chips, so just to let you guys know, because, you know. So yeah, that's probably another thing that's kind of annoying about machining is all the mess it makes. But good thing we have this enclosure. Okay, so that's pretty much that. Now we're going to go to our 3-flue end mill, which is probably not really going to get that good of a finish because it has been, these 3-flue end mills have been through a lot. Quite surprised they haven't died yet. Let's see which one looks better. All right. Draw the machine to the middle. It's also 1/4. 1/4 is probably like the best size for cutters, really. It's not too small and not too big, and not too much stress on the spindle. So I'll set the Z real quick for all these reasons. Bam. All right. Let's see here. We're gonna do a light coolant. So since this is a 3-flue and I don't want it to get clogged up. So the coolant valves are here. This is a very cheap thing on Amazon that you can get. I would probably invest in something better though, because this is just not the easiest control. course, we're gonna have a disaster here. So yeah, it is spraying this coolant. We are good to go. Camera view, second camera view. It's gonna go in and do a very low depth of cut on that, just to give it a nice forward finish. So it's getting rid of the stock technique that we added in, and I don't think you'll be able to see on camera, but it's definitely helping with that surface finish. Anyways, this whole thing is going to take a while because we're going pretty slow. This is mainly just for a test, really. We're just testing out what kind of adapters we can do, different shapes and stuff. I mean, what kind of wow, that is a beautiful finish, dude. Wow. I'm quite impressed. Kind of funny that the finishing takes longer than the roughing. Who's still alive in this live stream? Say hello in the chat if you're still alive. Right, I think it's now seeing its contours. Oh, now it's in. There you go. That is more like it. More or less, I think. That was a very, very. That was a very, very minor plunge right there. Good, now it just plunges. Yeah, the finishing really improved when we upgraded the Z-axis and also the X-axis. There's 5 views, but only 2 people said hello. It is very shiny though. I can't even tell pulling it on. Yeah, it is. It is very, very light. Yeah, this is just a USB camera that I put inside, so it's not the best quality. But at the same time, I don't think it's a good idea to put a good camera in there. It's so quiet, like really. So I feel like a portable vacuum is louder. Oh, hello, James. Yes. Let's do a test. Let's see if a portable vacuum is louder. So this is again, this is 12,000 RPM, so much lower, and that's just because we're using a 3 flue, and you risk clogging up the end mill. boring stream. Welcome to our main camera. Let's hear what's louder. Vacuum. Yeah, this small little vacuum is definitely louder. I feel like I can open this. Wow. Can I even move? Am I allowed to move the camera? Is that a thing people do? That is very nice finish. Much better than the aggressive adaptive. This is still adaptive, but again, it's just very slow. Wow. Very nice and shiny right there. It has a, I don't know, it sounds alright. It is very quiet. I don't even need the enclosure close, and chips don't go everywhere. Give it a little bit of coolant. Zooming in. That is an interesting shot. This is much safer to open too. There we go. That's the contour right there. It's a bit loud. Wow, that plunge though. What the fuck? Maybe let's not do that next time. Anyways, let's put this back to where it's supposed to be. Minutes left. I think I did a phasing operation. I'm not sure why it's not doing that, but I guess maybe I didn't save it properly. Yes, obviously the ML is gonna die from the camera. 1 hour, not bad. We're almost done, really. The facing is going to take a while. All right, so let's go back to Fusion here. So I guess I didn't save the facing operation. It's fine, we'll just do that later. So it's just doing these. It's on this part now, so it's on this last part. Just cleaning up the floor and then doing its sidewalls. Feeds and speeds, if you guys are interested. 60 inches per 66 actually. 12,000 RPM on a 3 flute end mill. If you put that into our very usable calculator, 12,000 RPM. Never mind. This is going to take too long. All right, anyways, back to the cam video. It's just chilling, you know? Like, this is probably like the safest part of this whole thing. It's just, there's nothing that is, the roughing is the scary part, for sure. Say hello if you're still alive. Let's do a live check real quick. Oh, thanks for increasing the views. So yeah, I mean, you know, these things are capable if you know, if you do different speeds and feeds. Obviously, you're not going to be able to achieve the speeds and feeds as the same as a male, but you're obviously, just you're gonna just really the end thing is to know is you're just going to higher RPM, really. Just that's pretty much the difference. So how's everyone's day? Liking the sound of the X3? I think everyone else just died. I felt like if I started on time, it would have been a lot more people watching, but it's fine. Just chilling here. Yeah, I'm not sure why it definitely sounds a bit quiet. I don't know. It's very, very hard to get everything right. I definitely need someone as the operator. Maybe we'll do this when we machine for Rov. About an hour into the stream, so not that bad. It's a pretty aggressive corner, really. I wonder, I might want to fix that in the cam next time. Yeah, and then during that time, we'll make sure to press live. Wow, a very aggressive corner. Should almost be done. I think it should be doing its contour now, hopefully. Yep, there it is. It's a very low frequency hum. It's almost interesting to listen to. Oh, yeah, probably should have moved the air blaster. It's fine. Shortcuts. There you go. Wow. That was uneventful. Nothing broke, so that's a good start. Okay. One second, let me fix my microphone stand. Let's see how we did. You've seen the chips are much smaller now. I don't even know if they're considered chips now for this finishing. These are, I'm gonna stick the vacuum and clean this up a little bit. You're gonna need to bring the big boys. Very, very loud, careful, watch your volume. Wow, this is quite nice. Let me show you guys. Very nice floor finish, very nice wall finish. Did I disconnect the camera? Apologize for that. Yeah, very nice finish overall. Smooth. Wall finish is pretty good too. Could be a little better. Maybe I'd just go a little bit slower, or I could just run it again, but it's fine. It's good enough for what we need it at. That's pretty hard to do actually, because yeah, I thought it was gonna cut that off. All right. So that is the finishing. I feel like I should probably move this clamp over here. It's probably at risk of getting milled out, which would be an exciting video actually. Where is my I think we're ready to just do the contours. I'm not gonna bother with facing because it doesn't really work that well after it's at this level. So we're just gonna go ahead and jump into the contour. Move this clamp just to be safe. Hope everyone is still alive. Yeah, so that's pretty much it. After the contour, we'll do finishing. And yeah, and we'll demonstrate the coolant now, because obviously the contours need that. So I'm going to change it to a single flute. Samuel did his job pretty well. He didn't clog up, so it's probably because of the coolant though. Which I should probably... And what do I need? What do I need? Ooh. All right, back to a single flute. And get ready for the exciting stuff. Zeroing the Z. Bam, done. So very fast, considering this is half an inch. I don't know how accurate that timing thing is though. Making sure we have a good amount of coolant on. This is the more challenging part. Closing the enclosure. Start it. Ooh, 24,000, so much. You just hear the sound difference. I forgot what this part is supposed to look like, but I guess I'll know now. Not engaging yet. Good thing we moved that clamp. There it is. Corner right there. Wow. So the cool thing with this camera view is you can actually see how much coolant is left. We also added a security camera on the top so you can see that too. So the contours aren't that loud. It used to be pretty loud, but since now we're doing coolant, and a more powerful spindle with how it should sound. So we're doing ramp in, and pretty much on any router, that's really the best that you can do. Yeah, it's very light coolant, but I don't know if you guys can see in the video, but I could definitely see water spraying into it. Well, not water, but yeah, coolant. We do have tape on the edges. That's probably... I'm gonna pause it real quick to fix that. Turn off the coolant. There are tape on the edges that I did not realize, and I don't really want the end mill. I'll just peel it back a little bit. Alright, there you go. This is nice and tight, right? Yeah, I mean, it already survived this much. I'm pretty sure it'll be fine. Actually, turn out coolant. Has a quite an interesting smell to it. So yeah, I mean, it's not. I don't know what could have happened, but I don't want the end mill clogging up with the tape. So. How's everyone doing? Say hello if you're still alive. Alive check. Okay. So let me show you guys the cam real quick. We are just doing it's fusion. Oh, good. It was about to crash. Anyway, so we're just doing this 60 inches per minute with 0.025, 0.02. I probably could go faster, but I just want to be safer. It doesn't take that long anyways. And then after this, assuming the stock is still in place, we'll do a finishing on a 3 flute, which just goes all around it really. Full engagement of the end mill. We're halfway actually, I think. It looks like it's halfway at least. So the cool thing about Fusion is that you can actually just right click and create an NC program, and then there's a Carbide 3D Gerbil right here, so it's almost like built in, and just click post and you get the file. That's pretty cool. Which makes it a lot easier to just go straight from Fusion to loading up the program. I don't think it's actually that loud, really. It's just quite impressive. So contours, we used to get really bad finishes on contours if we don't use coolant, and I'm guessing that's just the end mill clogging up. So now with coolant, that's not really a problem. This speed and feeds for the contours is not possible without coolant. We trust us, we tried. How's everyone's day? Just relaxing here. We're almost done actually. Very, very close to finishing. I don't know if it's gonna touch the floor. Oh, it might not touch the floor because the stock is kind of thick. It's not exactly half an inch. I'll just 0 to Z a little deeper. Yeah, I forgot about that. So we're gonna have skin on the bottom. Yeah, it didn't cut all the way through because the stock is much thicker than half an inch. I'm just going to set the Z a little bit deeper. That's a good amount of stock left. Or that sucks. That is a wow. The stock really isn't that flat then. Because it cut through here, damn. I don't know. I'm just going to do the finishing and we'll see what happens. It might mess it up. I don't think so, but I'll just set the Z a little bit deeper than what it actually is. We'll see. Watch this be the last thing. And mill stayed pretty well clean. So coolant definitely helps protect the coating too. Watch this be the thing that messes it up. Just a little bit deeper. We'll see what happens. It actually did cut through on some part, so this stock is just not that flat. It can't be the bed though. I measured the bed. Chip evacuation is a problem. I have a bad feeling about this, but YOLO. Oh, I'll run it once, and then it's not gonna cut through all the way, and then I'll run it again, but a little bit deeper, and then it should just cut through. So just to be safe, because I feel like it's really gonna mess something up. We'll see how this goes. Very scary. I am ready to press stop. Wow. All right, I mean, it worked, so now we're just gonna do that same operation, but a bit deeper, so it can cut through the skin. Whoa, that is a good finish. All right, good stuff, good stuff. So instead of wasting time and doing it in the cam, I'm just gonna manually set the Z as a little bit deeper. So let me go to where Z is. This should be good. We'll see what happens. Definitely want to pull it though. I'm kind of scared, but fingers crossed. Wow. So close. All right. Do it one more time, and then I think we should be good. Very, very close. And you can see the end mill has tape on it, as expected. Let me just get rid of that without cutting myself. Oh, so goddamn close. Like, damn. Go back to this. So we're just gonna do a little bit more, a little bit deeper. Alright, fingers crossed again. Alright, I'm pretty sure that went all the way through. I can't tell for sure. It didn't, but I'm not doing that again. Anyways, so there you go. So how the hell do we get this part out? Very good question. No one asked that, but it is stuck onto super glue, so it is a bit annoying, but a very easy way to do it. If I find the right tool, use one of these clamps, and I will just, well, push it out like this. Here we go. Oh, it's moving the stock first before the glue. Wow, that is quite tight. Let's clean this up a little bit. It's actually quite impressive. It's moving the stock before. Wow, this is not coming off. This is the last step, and we can't get it right. Damn. Did that just break it? No, it didn't, but it came off. I'm trying to think of a way to get this off. So, as you can see, we've learned that the super glue method is very strong. I'm gonna take the stock out. Maybe that'll help. If I could find the right screwdriver. Ugh, chips everywhere, dude. I'm not sure what to do. Oh, it's moving. No, it's just moving the whole thing. Oh, there it is. Wow. Fresh out of the oven. Except it's room temperature. So, let's take a closer look at this part. I don't know how I'm gonna do that though. So I'll just move the camera closer. Here we go. Well, let me do a quick wash on this part before I start, because there's some coolant on here. All right, final reveal. Very exciting. Look at that finish right there. Let me turn down the exposure on this camera. The finishing pass. Wow. Hello, autofocus. There is some skin left, which you can easily get rid of with wire cutters and probably a Dremel to Dremel that out. Maybe even deburr, but look at that. That is beautiful. The floor finishes are really pretty good too. Maybe I could do a little better, but they're shiny. This is overall a pretty good part. That is for sure. That contour is just very nice. Did this edge pretty well too. So there you go. That is how despite all the problems we had with the stream, I think overall this part came out pretty nice. Height wise supposed to be 1.25, so close enough. I don't know, caliper is kind of hard to use, but yeah. I don't remember the full length of the part though, but I'm sure it's somewhere. I don't remember. Alright, so there you go. Do I have a solvent? No, I just wash it with water, so probably not the best idea. It's probably this actually I really like this finish. This is a new method that I'm trying out, and it actually worked out pretty well. So this is really nice. I mean, it's nowhere like mirror finish or anything, and that's probably that's probably because of the end mill too. But yeah, it's a very nice cut. The floor finish is, you know, again, could be a little better, but very smooth though. Especially this. This is very good. This one is pretty good too. This one is okay. This one could do a little bit. It cut a little bit more on the contour. I think I needed to go in maybe a bit slower. I'm not sure. I'll have to check. Probably check the footage. That'll probably help too. But yeah, I really like this shiny machine look. And this was impressive. This was I wanted to do something a little bit more challenging than just cut off a square. So, and that's also why we have this piece over here. Sounds like aluminum. Well, there you go. That is the end of that part, and that's pretty much that. Wow, that is it's good to finish this actually. Wow. So that is this again probably used like I don't know. This is very thin foil. See, I'm ripping it off with my finger. I want to be careful. I don't want to get cut from it, but very thin edges that can probably be ripped off. But this is a very nice finish. So yeah, I mean the last time I did this didn't have as good of a finish compared to this. This was definitely much more appropriate speeds and feeds. Anyways, any questions, anything before we sign off? I'm gonna check the stream real quick. Good, Edisoni joined last minute. So yeah, that's pretty much that. Very happy so far with this part, despite again, kind of annoying in the beginning that it wasn't streaming properly, but at least we got the part done, right? But yeah, the finishing pass definitely helped. A lot. Will it focus? That is the question. Let me turn on the lights in here real quick. So the holes are alright. I mean, drilling operations typically do pretty well. I probably needed to go a little bit deeper. This is, holy crap, the camera. You can easily fix that with a hand drill though, but it didn't go. It went all the way through, but it didn't go deep enough. So that's pretty much the only real issue with the part. But yeah, I don't know what made the contour finish so nice, but wow, this camera does not want to focus. I'm gonna go to manual focus. I'm sure it's a combination of everything, you know. But these are really it feels very nice on the edges. I'm not sure what to do with this, like the excess material. I don't know, because it cut through all this. I went even a little deeper. I didn't want to go any deeper because I feel like it's going to cut too much into the bottom plate. But yeah, there you go. I will probably do a facing operation first. I'm not a huge fan of this look. So yeah, I mean, that's pretty much that. And thanks for watching, I guess. Again, this was supposed to be a lot more organized if it actually started, but it didn't. But it's fine. We still got the part done. That's what matters. And still went through the whole process. And oh yeah, coolant wise, so 1/2 inch. I have a good amount of coolant left. Barely using it. It was like I believe it was up here. I have to check the video, but I believe it was up here. Oh, my mic is positioned wrong. You know, if you aren't able to hear me well doing some part, it's because you're not supposed. Hold on. You're not supposed to use a condenser mic for stuff like this. Anyways, so this is the amount of coolant used. I believe it was up here. I have to check the footage, but you can see not a lot of coolant used. And yeah, considering this was 1/2 inch, that's a good amount of thickness. So this is probably the best surface finish I've ever gotten, really. And I think that's just a combination of using the 3 flute, using a lot more. I used a lot more coolant on the when it's doing this finishing pass. This is better surface finish than the end caps we made. And yeah, I guess that's just that. So the next time I'll probably be machining something a little bit more simpler. I'll be machining something simpler, probably like these key things, and I'll probably ship them out and stuff. I already checked the postage and stuff, if you guys are interested. So there you go. So machining on a router, well, if you're careful with your speeds and feeds, you can definitely get some very nice parts from it. You know, aluminum machining. You can probably even do a little bit of steel. You just have to go much slower and probably use a lot of coolant. So again, last questions before we go. I think that's pretty much it. Thanks for watching, and yeah, goodbye.